Oxygen has 6 valence electrons. It's only forming one bond with the nitrogen, okay? And again, we can go with the Cohen method and just go, oh, that's just one, or you can go with the technical version and go, oh, that's half of 2. Either way, you end up with the same things. So that's 6 minus 1, which gets me 5. And then I subtract 6, which is the number of unbound electrons. So oxygen still has 6 valence electrons that are floating around out there. So if you do that, you get -1. So in this structure, oxygen has a formal charge of -1. Carbon has a formal charge of 0. See how I got it? Okay. Now, if you go to the next structure, which looks very similar, okay, the chemical formula is the exact same. It's still hydrogen, carbon, nitrogen, oxygen. It's the exact same. Now, if you do the math, the number of valence electrons is still the same. That's 4 and 6. So it starts off the same way. Nothing has changed because that's just the number of valence electrons. So then with the carbon has how many bonds around it?
3.
So what type of hybridization is carbon going to undergo? It has 3 bonds.
sp2.
sp2. Because, you're making, see the pattern. So how many non-hybridized orbitals does carbon need? 1. Because of the fact that it needs to form that double bond. Okay, so when you look at this, so that's going to be a total of 6. So we're going to take 1/2 of 6. Now, how many electrons are left over around on the carbon? 2. So -2, you do this math, you get -1.
Wait,
Okay? So the formal charge on
hold on.
what?
2?
Or, I don't think you finished the dot structure for C. Or do you not?
Because, wouldn't there be 2 with the nitrogen, 1 with the hydrogen, and carbon has 4?
No, he's right. No, that's right.
Then where am I wrong?
There's 2 valence.
Because it's making 1 electron is going here, and then
That's right.
1 electron. I'll get back with you on that one.
Thank you.
I'll hold that thought. Okay. So kind of. Okay. I'll have that. That's his wheel.
I'll just be quiet the rest of the class.
Okay, no, that was valid. Okay, so then if you go with the oxygen, okay, because that one's still cool. So oxygen is making those 2 electrons that are going to form that bond. Half of that, you get 4. That's going to be 4 valence electrons out there, and you're going to get 0. Okay? So here's the difference, and this is typically how the question plays out. It'll say, here's your 2 possible structures. The first one has a formal charge of 0 on the oxygen, and it has a formal charge of -1 on the oxygen. This one has a formal charge of -1 on the carbon. This one has a formal charge of 0 on the oxygen. So if you were just given that information, that's typically how it plays out. Which one of these is going to be the preferred structure? The first one or the second one? First one, why?
The oxygen and
The oxygen has the higher,
electronegativity.
and that's the one that should have the formal charge. Okay? That's a negative value. So on these 2 structures, this is the one that's going to be the most stable and the most preferred. Okay? All right. So there's nothing out of the book. Okay? This is just a free response question. Do not answer this on this sheet. Okay? Do not answer it on this sheet. I'm just telling you.
Or bad things gonna happen. Bad things. Maybe